Hello, March for Life pals. I am going to make a video, obviously, of me doing the note packet for 7-6. So I'm on 7-6 exponential functions right now. I'm just going to work through these. I know your attention span for videos is shorter than it is even in class, so I'm going to try to go kind of fast. If you need to rewatch things, you can rewind and rewatch them. And then I'll also upload a PDF of the notes for you to copy. And then you can do the assignments, which are already listed on the front of your packet. Okay, so I'm on 7-6 exponential functions. Our problem of the day is to sketch the graph 2x plus 6y equals 12. So this is not in y equals mx plus b form, this is in standard form. So to sketch that graph, I figure out what x is when y is 0 and what y is when x is 0. So I'm going to do, hold up, there we go, 2x equals 12, and then 6y equals 12. If 2x is 12, we would divide by 2 on both sides, so x is 6. If 6y is 12, we would divide by 6 on both sides, so y is 2. And so then I can sketch my graph. On my x-axis, it would cross at 6. X goes this way. So 1, 2, 3, 4, 5, 6. On my y-axis, which goes this way, it crosses at 2. 1, 2. And this is just a sketch. It does not have to be perfect. So it would look something like that. I know this is going to be hard to see in the actual video, but hopefully me talking through it will be helpful, and then you can look through the PDF. Okay, so today we are talking about exponential functions. So basically, we already talked about functions without exponents. We're adding exponents now. So the equation for a linear function is y equals mx plus b. We already know that. The equation for an exponential function is y equals a times b to the x power. We will get more into that about what those things mean and how to work with that. Okay, so the graph of a linear function always makes a straight line. It's linear, it makes a line. Exponential functions have these curves to them. And we'll get more into that later. But you can recognize them by this curve feature that they have. So if there's a curve like that, you know that your formula would have an exponent in it. Okay. So if I was writing the equation from a table for a linear equation, I would find my difference here. So from 5 to 3 in my y's, that's minus 2. From 2 to 1, it's minus 2. From 1 to negative 1, it's minus 2. And then, we're just marking the table. We're not writing the equation. But it crosses the y-intercept at 3. So it'd be y equals negative 2x plus 3, because that's my y-intercept. If I was doing it from an exponential function, you'll notice here it was like adding or subtracting. With exponential, it's always multiplying. So to get from negative 1 to negative 3, you would go times 3. From negative 3 to 9, you would do times 3. From negative 9 to negative 27, that's times 3. And at 0, it's negative 3. So my initial value is negative 3, and then it's times 3 to the x power. We'll get more into writing those later. Okay, so, and that's more next chapter too. Okay, so we're gonna look through these tables and these rules and say if they are a linear or an exponential function. So looking at this table, from 1 to 3, and 3 to 9, and 9 to 27, it matches what we just did. You're multiplying by 3 each time. Because you could do minus 2 on the first one, but that doesn't work for all of them. So that's how I know it has to be times 3 each time. So that means it's exponential because it's being multiplied. Exponential. I can spell. For this one, y equals 3x. There's not an exponent. That would just be a linear line. It would start at 0 and my slope would be 3. So this is just linear. This one I can super quickly see it has an exponent, so it's exponential. Exponential. Cool. Okay. This one, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2 to the x power gives the population after x weeks. How many beetles will there be after 56 days? Okay, first we need to note that this says 56 days, but this is talking about weeks. So I first need to figure out how many days or how many weeks are in 56 days. So there's 7 days in a week. 56 divided by 7 is 8. So I'm trying to figure out after 8 weeks. So then all I have to do is take this 8 and plug it in for x. So it's going to be 30 times 2 to the 8th power. 2 to the 8th power is 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64, 128, and 256. So it'd be 30 times 256. And then you can just use a calculator when you multiply those. I will tell you, you would get 7,680. So that's how many beetles you would have after 8 weeks. Woohoo! Next one. An initial population of 20 rabbits triples every half year. The function f of x equals 20 times 3 to the x gives the population after x half year periods. How many rabbits will there be after 3 years? 3 full years into half years would be 6, because there's 6 half years in 3 years. So instead of 3 years, let's do 6 half years, because that's what my x is in. So then I just plug 6 in for x here. So 20 times 3 to the 6th power. And then 3 to the 6th power is 729. So it's going to be 20 times 729. When you multiply that out, you would get 580 bunnies, rabbits. 14,580 rabbits. Can you guys even see? I don't know. Okay, next page. We're gonna graph. This looks really scary, but it's actually not that bad. They just want us to graph this function. So we're gonna put in, for the x values, -2, -1, 0, 1, and 2. That's just kind of the standard what you can plug in to check your graphs. I'm gonna scoot this a little bit and see if it helps. Okay. So I'm gonna plug each of those in. I accidentally gave an extra line, sorry. I don't know how to count. So you're just gonna plug in each of these numbers in for the x value. So I'll have 3 times 2 to the -2, which is 3 times 1 over 2 squared, which is 4, and 3 times 1/4 is 3/4. And then 3 times 2 to the -1, which is 3 times 1 over 2 to the 1, which is just 2. So 3 times 2, which would be 3/2, or 1.5. For 0, it'd be 3 times 2 to the 0, and anything to the 0 power is 1. So 3 times 1, which is 3. 3 times 2 to the 1 power, which is just 3 times 2, which is 6. And then 3 times 2 squared, which would be 3 times 4, which is 12. And then we're gonna put each of those points in. I'm trying to see if you can actually see it in this video. So we have a point at -2, 3/4, -2, 3/4, -1, 1.5, 0, 3, 1, 6, and 2, 12, which would be way up there. So it looks something like that. Just one more. Okay, so this one is 0.5. 0.5 times 3 to the x power, and we're gonna do the same thing, plug in -2, -1, 0, 1, and 2. So 0.5 times 3 to the -2, 0.5 times 3 to the -1, 0.5 times 3 to the 0 power is just 1. 0.5 times 3, because 3 to the first power is 3. 0.5 times 9, because 3 squared is 9. Now I'm going to go back and answer those. So this would be, I'm going to write them as fractions since this will be a fraction. That's easier to me. So I've changed my 0.5 to half. and then that'd be 1 over 9. So it would be 1/18, because 2 times 9 is 18. This one would be half times 1 over 3, so that's 1/6. This is half times 1, which is just half. Half of 3 is 1.5, and half of 9 is 4.5. So now I'm going to go through and put those points. -2, 1/18, that's just going to be like barely above 0. -1, 1/6, also not very far above 0. 0, half, 1, 1.5, 2, 4.5. My graph would look something like that. That is it for this lesson. So then you'll go back and do the assignment. Page 457, 8 to 19 all. Feel free to email me with questions while you work on it. And March good.